have decided to do a little video for you to explain the next part of the course because I think it would be really helpful. I hope it would be really helpful for you to be able to go back and watch the explanation again when you're trying to consolidate your understanding. Okay? So last lesson was all about displacement reaction. So hopefully you recognize this drawing as showing a metal displacement reaction. And remember the things that we're looking for. We're looking for a more reactive metal being placed into a solution that contains a less reactive metal. So if we look at our activity series, which we will go through in more detail next week and you get given in all exams, magnesium exists above copper in terms of that activity series. Okay, so that means this reaction is going to happen spontaneously. And we looked last lesson at how to write those out. So we know that it's magnesium. We know it's reacting with copper sulfate, and that copper sulfate is aqueous. Because this is more reactive than this, we know a displacement reaction is going to happen. Displacement means swapping places. So we're going to get magnesium sulfate, and we're going to get copper as a solid. So again, remembering that we'll see changes happening in this solution as well. So we know very well by now that copper sulfate is nice bright blue. If we're getting much less copper sulfate because we're getting a positive copper being produced, then we're going to get a decrease in the colour. And we also know something's going to happen to this metal. Okay, so magnesium's going from a solid and it's forming an ion. So you actually might start to see parts of the magnesium break down over time. And you'll also see this copper, which is going from ions into a solid, depositing onto the bottom of your beaker. So lots of things that you can visually see to tell you that a reaction's happening. What we want to look at today is what we can't visually see. So we want to start looking at where the electrons are coming from and where they're going, because an understanding of that is going to help us understand how batteries work, basically. So the first step, you need to break down this equation into ions, leaving anything that is not ionic in its natural state. So magnesium as a solid is not an ion, it's a solid. It's just an element, it's neutral. Copper sulfate. Your hint is it's an aqueous solution. Aqueous solutions are generally made up of ions. This is going to be made up of copper ions and sulfate ions. Magnesium sulfate, aqueous solution again, polyatomic ion, hinting at us that it's going to be made of magnesium, it's going to be made of sulfate. Copper as a solid, that's its natural state. It's not ionic, it's elemental. First thing that we need to do, and hopefully you're starting to go, I think we've done this before, because we have. We spent a little bit of time doing some half equations last term before you started your depth study. Okay, we now need to look at our net ionic equation, which is what you've just written, net ionic. And we want to get rid of any spectators, which means things that don't do anything. They're not involved in the reaction in any way. There's no change in charge. So magnesium is a solid, been converted to an ion. So it's done something. Copper as an ion has been converted to a solid. It's done something. Sulfate as an ion has remained sulfate as an ion. It's not done anything. We get rid of it. It's a spectator. We're then going to rewrite the equation just because it starts to make it look a little bit clearer once you've gotten rid of your spectators. Okay, I've got copper solid. Okay. So it starts to become a little bit clearer now where the exchange of electrons is happening. So one metal's got to be giving them up and one metal needs to be accepting them. If magnesium has gone from neutral to a positive ion, it must have given away electrons, because at this point the number of positives equaled the number of negatives. That's what neutral means. So if I now have two more positives than I did before, two more positive charges, I've gotten rid of some of these negative charges. Okay? Opposites happened with the copper. Started with a positive, ended up as a solid, neutral. So it's gained the 2 electrons that were given off by the magnesium. So these things are the same. Magnesium gives the electrons off, copper accepts the electrons. Those 2 things together are called a redox reaction. Okay? We can look for redox reactions whenever there is an exchange of electrons, which basically means whenever there's a reaction that has a metal in it, it's likely to be a redox reaction. But we can look at ways to recognize that a little bit later. Okay. So I'm going to look at another example, and then I'm going to get you to have a go at doing a few, and I will be hanging in the Google Meet to go through any more details with you if you need it. Okay. So one more example, and I'm going to go a little bit faster. Magnesium sitting in hydrochloric acid. I really hope by now you can all write this equation almost without thinking about it, because you have looked at it many, many, many times. 2 Cl's, 2 H's, I need to balance. Then I need to break that down into my ions. Solids are not made of ions. Hydrochloric acid, aqueous solution. It's made of ions. 2Cl minus. Why have I got 2 of each? Because there's a big 2 in front of the whole HCl. So there's 2 H's, there's 2 Cl's, so I need to show them separately. Magnesium chloride, aqueous, it's made of ions. Mg2+. We know it's 2+ because periodic table tells us it's in group 2. Chlorine, we know chlorine's -1 because it's in group 7, needs to gain 1 electron to form an ion. 2 chlorines, because there's a 2 down there. H2 as a gas, that's its natural state. It's a diatomic molecule. It's not ionic, it's covalent. Get rid of our spectators. I always like to use a different colour just because. Chlorine is a spectator. Let's rewrite. Okay. Starting with magnesium again. It's forming Mg2+, plus 2 electrons. Okay, general rule of thumb. When it's going from a solid to an ion, it's getting rid of electrons. If there's only one metal in the equation, it's the metal that's getting rid of the electrons. Then we've got 2 H pluses. If the magnesium's gotten rid of 2 electrons, that means the hydrogen has gained 2 electrons. And it's forming H2. And we're all nicely balanced. So what you're going to do now is you're going to have a go at trying to work out the half equations for each of these equations. So you have sodium reacting with phosphoric acid. We know that that produces sodium phosphate and hydrogen gas, acid plus metal. Magnesium and oxygen, hopefully you know that that produces magnesium oxide. A metal plus an oxygen gives us a metal oxide. Then I've got calcium and iron chloride. So 2 metals. It's not following your usual acid plus metal, acid plus base. Okay? When you've got 2 metals in solution, hopefully you're recognizing that that's a displacement reaction. Calcium is more reactive than iron, so we're going to get the iron coming out as a solid, and we're going to get left with calcium chloride. Okay? So I've done step 1 for you. You need to balance the equation. You need to break it down into the net ionic equation. You need to get rid of any spectators, so things that do not change. You need to look at the charges to work out what your 2 half equations will be. So you've got one equation where electrons are gained, and you have one equation where electrons are lost. If you need to, go back to the beginning of this video and watch my explanation again, and then have a go at these 3 examples. Happy Friday!